those. All right, so finding the slope of a line. Okay, so finding the slope of a line. Slope is referring to the steepness. If you think of like in a non-math context, if you're talking about a slope, you're talking about like a ski slope, right? And the ski slopes that are steep are the really dangerous ones, and then you got the kiddie slopes, which are pretty flat. But that's about the steepness. It's represented by the letter M. Because the same thing as a magnitude. Okay, so that's where the M comes from. Because you might think slope, M, doesn't make any sense. Well, S in math has already been taken up by like speed. So we use M for magnitude. Of course it is. There are several ways to write the formula to calculate slope. You can have the letters, the y2 minus y1 over x2 minus x1. This is the one that we will most predominantly use right here. But what that refers to is the change in y over the change in x, and it's otherwise known as rise over run. And this is the one we'll use when we are going from a graph. So for this one would be from given points. And this one would be from a picture graph, picture. This is just what it means. So the rise is how far up or down you go. And the run is how far you go right or left. Okay. Now when you're counting rise over run, if you go up and then to the right, you'll have a positive number. If you go down first and then to the right, you will have a negative number. Yeah, but if you go up or down, I think personally, for a lot of people, it's easier to think in terms of up and down as being positive and negative. So if you always go up or down and to the right, the up will correlate to the positive and the down will correlate to the negative. So this is what I recommend. If you go down and then to the left, you're positive. See how it's backwards? So if you go down and left, like down and left, it's still positive, but you're going negative, negative, and that's what makes it a positive. And I don't think that's quite as, yeah, it's not as natural as going up to be positive and then just going to the right. Does that make sense? Right, and down is also negative. So you're having a double negative, but the two negatives don't automatically make people think, ooh, positive. And then if you go up and to the left, you're negative. So I recommend more of using these to help you remember positive and negative. The other thing is as you read the page, if you read a piece of paper, you read this way. If you move this way as if you're reading and the graph goes up, it's positive. If you move this way and the graph goes down, it's negative. So as long as you're moving in the same direction you read, the up and down will also indicate positive, negative. Any questions on that part so far? All right, so here's an example. We want to find the slope of a line given the equation, and we have to make sure the equation has been solved for y before reading. So the slope-intercept form of the equation is y equals mx plus b. M is your slope. B is your y-intercept. This is where it hits the y-axis. So what we do is we have to turn this equation into y equals mx plus b. And this is what's called standard form. We have x y, and then the number. There's two ways to do this. We'll go with traditional and then Miss Ayton method. Let's do the two methods. The traditional method tells me to subtract 2x from both sides. Just going to be flipping back and forth, which gives me negative 4y is equal to negative 2x plus 7. And here's why I don't like the traditional method so much, because sometimes this confuses and people subtract the 7 minus 2. But there's x's and no x's, so they can't combine. Then we have to divide everything by negative 4. Leaving me with y. Negative 2 over negative 4. Well, 2 doesn't divide by 4, but they both divide by 2. And since they're both negative, it becomes positive 1/2 x. And then 7 and negative 4 don't divide at all. So I'm just going to make that fraction negative, because I have the negative in the denominator. So I get y equals 1/2 x minus 7/4. And this is in slope-intercept form. Now the Ms. Ayton method, I'm going to pick this up and I'm going to move it over here. So I'm going to change sides, which means I have to change signs. Okay, so anytime I pick something up and move it, and I move to the other side of the equal sign, I have to change signs. Just like when a sports person switches teams, they change jerseys. Same person, looks different. That avoids this possible confusion of combining these two things that don't combine. I just pick it up and move it, and then it's very easy to see that they don't combine. Then I have to do the second part the same. I divide everything by negative 4. So I have the positive 1/2 and then the negative 7/4. Okay. And the slope is 1/2. Horizontal lines have no slope. Flat. Flat equals 0 slope. Okay. And in the equation, it's y equals n, where n is the number where it hits the y-axis. Okay, so if this was like 1, 2, 3, 4, if that was that would be y equals 4. Okay. Vertical lines have a slope that is undefined. So if you're up and down is a W, that's a W. Okay, undefined slope, and it's x equals n, and this is the number where it hits the x-axis. So if this was, say, 1, 2, 3, this line would be x equals 3. You just find the number where it hits the axis, and you can always tell which letter. If I just gave you like that, and I gave you a line, and I said, what's the equation of that line? And you can tell if it's y or x, because it will hit only the y-axis or it will hit only the x-axis. And that tells you it's y equals or x equals. Does that help? Okay, did anybody need to write that down? So if we're given 2 points calculating the slope, they say straightforward, plug it in. I like to call this plug and chug. As you plug it in and then you chug it out. Okay, you'll see. Okay, so here we have the point, the line passing through 5, negative 1, and 7, negative 9. And actually, lost my pen. Okay, so I have x2 minus y1, or y2 minus y1, x2 minus x1. So this is x1, y1, x2, y2. So I've labeled those. Now I plug them in. So y2 is negative 9, y1 is negative 1, x2 is 7, x1 is 5, double negative is a positive, so that's negative 9 plus 1. So negative 9 plus 1 gives me negative 8. 7 minus 5 is 2. Negative 8 divided by 2 is negative 4. So there's my slope. So you see I plugged, and then I chugged. Just as a note, it doesn't matter if you call these the 1s or if you called these the 2s. Like if this could be x2, y2. And this could be x1, y1. That it doesn't matter which point is which. The only thing, you can't have x1, y2 in the same point. They have to both be 1s or both be 2s. But it doesn't really matter which one, because if I did it the other way, I would have had negative 1 minus negative 9 over 5 minus 7, which would have given me 8 over negative 2, which would have given me negative 4. So it really doesn't matter which point is which, just that they're both 1s or both 2s. And that the y's are on top and the x's are on the bottom. And that if this is the first one, then this one has to be the first one. You can't do, say, 5 minus 7 and negative 9 minus negative 1. You can't. They have to go in the same order. Now that I've thoroughly confused you, let's move on. Okay. Now, I have x1, y1. Let's say I'm just going to call this x1, y1, and this is going to be x2, y2. But x2 is an x. And I know my slope is negative 3. So I'm going to plug in what I know. Okay. Then I'm going to simplify it. So that's negative 11 plus 2, which is negative 9 over x minus 1. Now I have to make a proportion. Do you guys remember proportions? It's when a fraction is equal to a fraction. So to turn this into a proportion, I'm going to add a 1 underneath it. I can turn any number into a fraction by putting it over 1. And then I'm going to cross multiply. Okay. So when I do that, I'm going to get negative 3 times x minus 1 is equal to 1 times negative 9. So I'm going to distribute this negative 3. Which is going to be negative 3x plus 3 is equal to negative 9. I wish there was an easier way to do that. Subtract 3 from both sides. I get negative 3x is equal to negative 12. Just divide both sides by negative 3, and I get that x is equal to 4. So first I'm going to plug in. I simplify. And then I solve the proportion. So cross multiply, then solve. Find the slope of this equation. Everybody, tell me real quick. The slope of A.
6.
Close.
2.
2. Slope is always attached to the x. So m, slope. Okay. For b, okay, I'm going to pick this up and move it. So I have 3y is equal to negative 9x plus 12. Divide everything by 3. Y is equal to negative 3x plus 4. What's the slope?
3.
Negative 3. So this one I'm going to do 12 minus negative 5 over 4 minus 1, which gives me 17 over 3, which is perfectly lovely. I don't have to do anything to that 17/3. I just leave it 17/3. And here I have negative 13 minus negative 3 over 15 minus 15, which gives me negative 10 over 0. And what happens when I have that 0 in the denominator? Is that allowed? No. So it's undefined. If you have a 0 in the denominator, it's undefined. If it's a 0 in the numerator, so if it was the other way around, that would just equal 0. Okay. Oops. All right. Come on. I froze it. Boom.